So our today's topic is about the linear regression and how we're gonna find out and predict something out of the linear regression. So if we talk about the linear regression and the prediction, so if I choose like a movie which hadn't been displayed in Pakistan, but today we have a rating on this movie where we have a rating of 8.8 out of 10 in IMDb, but that movie doesn't display it till now. How? That IMDb is able to find out the automatic predictions of the rating of the movie. So for the e-commerce website, so our today's goal is how many followers will I get in the prediction. So we're going to predict with the help of regression and the regression model. How are we gonna predict how our regression model work and how are we gonna able to find out what kind of model do we have to work on this kind of data set. So today we are to talk about all the kind of data set, as well as we are going to implement some linear regression model on different kind of data set, and we are able to make our own regression model. So we are able to predict, and for the longer run we are able to find out the gradient descent. So we can even predict more further with the help of gradient descent. So let's start with the Google Colab. So here we have a Google Colab in which I'm going to have a model already, name I already made up on it. So I'm going to have, which for the display, I'm going to matplotlib inline. So I can show my display in the screen because I need a display when my model is going to be trained and when my model is going to be happen. So IPython, I'm going to have a display. So I'm going to have a display from it and import. Today I'm going to use an HTML because we are on the web interface. We are only a web interface, so we need an HTML display. And okay, so from NumPy, I'm going to have each and every file which includes in NumPy. So I'm going to use star if I'm going to use and to find out all the libraries, all the things in the NumPy. So I'm going to use a star, and I'm going to have import matplotlib as plt. Nothing else I'm going to have. So I'm going to run it, and yes, it's working. Now I'm going to find out what type of data set do I have. So I'm going to import the sample of my data set, and I'm going to have a sample data set. And oh yes, sample data, I just got it. And when I got my sample data, it show me here that I have a sample data in my list. And then with the help of simple data, I'm going to import a data from some kind of URL. So I'm going to import the data from URLs that I already have a URL, so I can import the data from that. So URL lib dot request. So I'm going to request the data for my URL retrieve, RETRIEVE, retrieve data. Now I'm going to have a data from any URL. So I have the URL. I already took the URL for my data set. So this is my URL, and I'm going to use this URL in this way, so I can have my whole data. Yes, without a space. So be careful while implementing a space, because this language is critical with the spaces. So I'm going to run it. That do I have my data? And I got an error. And what kind of error do I have? Okay. I missed the H in HTTP. So let's see. And yes, I have my data. So I have my data. So I'm going to have, do I have my data in my sample? So yes, I'm going to check the list. List. Do I have my data? Okay, it will take a little bit time. And it will show me something very quick. It will take a little bit time because I'm currently using an environment of Zoom, so it will actually connect it towards each and every application, the list. So it's actually calculating the whole list out of this one and fetching the data So it will, yes, it happens. And yes, I have my data. And yes, I have my data with me. So now I'm going to make the model like this way, so I can have my data as well as my model of the linear regression. So now, as I told you, it's happens while recording online material. So it will check each and every file connected. So we have our data in CSV, and now I'm going to make a function so I can have to access my data. So I'm going to have a data. So generate from text into CSV. So it's data dot CSV, and I'm going to separate that data with the help of delimiter. It's DLIMETR, delimiter. Delimiter is sort of space, and I'm going to show it with the help of comma. Now, extract columns. I'm going to find out how many columns and how extract columns from, it's just like extract columns from my data set. That's it, nothing else. So X is equals to X are the rows array out of my data and starting array from nothing and end up with 0. And from Y are the columns. So I'm going to find out each and every column in my data set. So it's array, data, and then starting and with 1. Now I'm going to show what type of data do I have. So I'm going to plot graph for my data set. So I'm going to plot my graph. So plt dot, I'm going to find out the type of a graph. It's scattered between X and Y. I'm going to have a graph, and in my graph, I'm going to have a 2 or 3 labels. So it's like plt dot X label, and in X label, I'm going to find out hours of study, which is the part of my data set. And then plt dot Y label I'm going to have, and in which I'm going to find out the test. Okay, it's like test score. Now you are curious about how I got to know about the Y and X labels in my data set. So I'm going to show you how you are able to find out what kind of data do you have in your data set. Let me complete this. So plt dot, I'm going to have a title, title of my data set. So it seems like we have a data set. That's it. And I'm going to show my plot is plt dot show. That's it, nothing else. And I'm going to have it run it. And yes, I have my data set. So this is my label, and it's working in hours of study and how much test score do you get in the working of hours. So how I'm able to find out what kind of data set do I have. So I'm going to show you. It's like I'm going to read my data set. It's pandas as PD, and it's like data is equals to PD dot read underscore CSV, and we have data dot CSV. It's an easy way, or otherwise if you are going to have the data, so just copy the path and just you have to print it here, and you will have and data dot head. So here you go. This is how you're gonna have your data in your data set. So you have a data and you have 2 labels, hours of study and the test scores you'll get. And this is your data in the form of output. So with the label and the data, you'll get this kind of data. So I'm not going to include this part in my thing. Now, I'm going to use the learning rate and then cost function, then the gradient descent. So forget this part. And then now the most important part I'm going to use for hyperparameters for my linear regression for LR. Now I'm going to use the learning rate where I'm going to train my data. Now I use my model. Now I'm going to make a thing possible that I can train and test my data, but before that I'm going to use and train my model through which I'm going to test my data. So I'm going to use learning rate. It's LEARNING learning underscore rate, which is equals to 0.0001. Initialize, I'm going to use initial TIL underscore B, which is actually a weight, which is equals to 0, and initial weight M, INITIAL, initial underscore weight M, which is also is equals to 0 from the start. Now I'm going to use the how many times do I get to change the weight? Maximum I'm going to have a 10. It's the hyper values. It's the hyper value I'm going to have. It's hyper values I'm going to have according to this one. So this is initial B and this one initial M. And how many times do I have to repeat the whole process? So it's like 10 times. Now I'm going to run it. Yes, my function is, my things are working good. Now I'm going to use how I'm going to compute the cost. Now I'm going to have the cost of my function. As I told you, now I'm going to have to find out the cost of my function out of the box. So I'm going to define compute cost. It's not the cost in the money. It's a cost where it's a cost like how much do I get and how much do I lose in my data or in prediction or something like it. So it's like B comma M comma data. Now the total cost right now we have it's equals to 0, and then now I'm going to find for the number of data points do I have to train on it. Number of data points do I need for training? I'm going to use some kind of n number of data points do I need for the training in float, and it's going to be length total get about the data. That's it. Now I'm going to find out the sum of square error. That's the thing, square error. The sum of square error I have to find out between y and t time, or in our case it's y and x, y and x, y and x, y and x. So what shall we have to do is to find, and it's like compute sum of square error. In our case, we are going to find out the sum of square error. So for I, and it's not like for I in range, I'm going to use the iterative loop as I told you above 10 times. So it's gonna be like starting from 0, comma, length of the data, how much data we have. So it's gonna be work according to that thing. So x is equals to data I, comma, 0. Y is equals to data I, comma, 1. So we are going to have a graph accordingly. So total, TOTL, total underscore cost, which is equals to plus. Now I'm going to make a formula. The formula which we have here. Now this formula I'm going to use, it's for y, like we have a t, but here we have a y. So I'm going to use y minus bracket this function. It's like m, we have multiply by x multiply by p and raised to power 2. It's a function, complete function. So it's raised to power 2. The whole function is raised to power 2, so it's raised to power 2. Now, so if I'm going to code is like, I'm going to just write the function out of that thing. If I'm able to write over here with the hash, so I guess, okay. So this is that function which you have. So the function we have actually formula for MULA formula we have. Now, according to the formula, we need some kind, something in return. So I'm going to use return total, total underscore cost divided by 2 multiplied by 2 raised to power 2 multiplied by n. So this thing I need in return of this cost function. So I'm going to run it. Okay, so it's computing the whole formula out of the cost and the data, and it's working. Now, why it's not showing anything? Because I didn't make to show it anything, because we are going to have something in a longer run. So it's just nothing before. Now, what we have, now we are going to have a gradient descent function in which we are going to code the linear problem. So it's like define step. It's like I'm going to have GF, the gradient descent function, in which we are going to have finding the value of B current. What value do we have? So B current comma M current and the data and alpha. Alpha is just like, as I told you before, it's just like a value. We don't even, it's alpha. In that case, before we are going to have a value without alpha. So gradient descent. So I'm going to define the values of my gradient descent. So M underscore GF, gradient descent function, or M underscore G you can say, which is equals to 0. And then B underscore G, which is equals to also 0. Now, N again, number of data points, float, length, finding the data. Now the calculate gradient. Calculate the gradient. So as we know, we are going to use loop in range of where range that starts 0 length towards the data. And again, we are going to repeat the same process, but at this time, we're going to have repeat the same process, but at this time, we are going to have a little bit slightly a different thing. So this process can be with the same thing. So now with mg, which is equals to plus minus 2. Now the formula. Now this formula I'm going to have, it's 2 divided by n multiply by x multiplied by y minus m underscore current value multiplied by x plus b underscore current value that's it. And same we are going to do with the b underscore g, b function of gradient, which is equals to, so it's actually I'm going to have a comment over here, so it's gradient function. So here I'm going to have a formula as well. So what formula we are getting? So it's this formula we are actually have right now. Okay, so in the b gradient we are going to repeat the same function with the same value, but a little slightly a different one. How? It's like it's gonna be the whole, but it's gonna be whole the same, but without the value of x. That's all. Nothing else we are going to have to change, because in our gradient descent or gradient function we have just one value ahead of x and ahead of y. Why? Because while we are going to have a training case, in our training case we always have one value ahead and one value down, so that's why. Now the more important thing we have to update the value of m, update the value of m and b. How are we going to do it? It's m update. I'm going to make a function which is equals to m underscore cur current value minus alpha which we already have above. Currently alpha has nothing in it, and multiply by m underscore g. Same we are going to repeat for the b update. So I'm going to have the same function, and it's going to be like b and b current and b update. So both of our values has been updated. Now I'm going to return the updated values, return the update values, so we are able to find out what kind of data set and what kind of learning prediction do we have. So it's like return b underscore update comma m underscore update. So we have both values. Now from the above values I just figured it out how to calculate the gradient out of the box. Now I'm going to initialize another function in which I'm going to find out the gradient descent. Gradient underscore descent, in which I'm going to have a data and starting value s underscore b value, comma s underscore m value, and learning rate LR, and number of iteration. So it's ni, number of iterations. Now I'm going to start with two variables initialize the value. New values is like, so b is equals to s underscore b and m is equals to m underscore b. Two values. Now I'm going to find out the cost of my graph to store each and any store the value. So it's like cost underscore graph graph, which is equals to empty array. Now I'm going to find out the progress. How much progress do I have till now? So it's b underscore progress for p, which is equals to this, and m underscore progress for p, which is equals to empty arrays. Now for the iteration loop, for the iterative loop out the whole data, I'm going to use loop for I in range of what. Now ni, number of iteration, how much iteration do we have right now? We have no idea. So what we get from cost underscore graph dot append the function of Python, in which we are going to find out the compute cost, which we made above, the compute cost, this one. I'm going to use that function below down, compute underscore cost of what? Of b comma m comma data. So I'm going to have the compute cost. So b comma m comma, I'm going to reinitialize its step gradient, its gf, which I made a function in the start. So which is equals to, I'm going to use is equals to gf, and in that function what we have, it's b comma m comma array of data and the learning rate, it's LR for learning rate, we already mentioned above. Now find out the progress. Now it's b underscore p dot append of b, and it's m underscore p append of m. Now I'm going to return the function, the value. So it's return b comma m comma cost underscore graph comma b progress b underscore p comma m underscore p comma, that's it. So I'm going to run this function. Let's see. Okay, we are good to go. Now I'm going to use the optimize parameter, in which I'm going to use the optimize across timing parameter, in which I'm going to put this formula, and I'm going to apply this formula. So it's optimize the values, in which this formula I'm going to make. So we have int, oh, before that I'm going to have, okay, so b comma m comma cost underscore graph comma b underscore p comma m underscore p, which is equals to, now I'm going to have or function, the gradient descent. I just have to make it over here, so I'm going to copy the spellings because the spelling is much important over here. It's gradient descent in which we have a data, comma, inititil initialize underscore b, comma, inititil initialize underscore m, comma, iteration, comma, learning rate as well. That's it. Now I'm going to print how much value do I got the optimized with the help of all those function of b, parameter of b, how much value I got in optimized b, and same I'm going to have in m. These are the two variables we got from the start. And how much cost do we have in my minimized function? So it's like how much loss do we got using all the parameters. So it's minimized cost, which we are going to have compute underscore cost of what, b comma m comma data. That's it. Okay, it's b comma ni is not defined. Why it's ni is not defined? Okay, so it's all about the pattern. Maybe I get it dot ni. LR is not defined. Why LR is not defined? LR is a learning rate, so LR is here. In gradient descent, we have why LR is not defined. Okay, got it. We actually, I put this like LR, learning rate, and it's NI, the initial one. So just have to write, okay, so let's make it run. M underscore B is not defined. Why M underscore B is not defined? Where is M underscore B? Why M underscore B? Where we used it? M underscore B is not defined. Okay. It's a progress. It's a cost graph progress. So why it's not working? It's cost graph. Where I use B. New values. Where are second new values? Starting and ending value. Starting of B and ending of B. didn't utilize these values. How is that even possible? We don't use these values. Wait a second, it's STARTING starting underscore B. So, okay, I got it. It's S underscore B and S underscore M starting values. So let's see. Still we having M underscore B. Okay, so run it. It's running now. Okay, so now and again it's self engine. It's keyword of 0 by 0. How do I get that problem? Okay, so it's in, okay, got it. So actually it's in way, okay. So I just changed the values to do to the whole thing. So we are able to find out, yes, and we have our values in which I'm going to have each and every, the data optimized and minimized cost of my function. Now it's time to put a graph over what we had done. So it's a plt dot plot. I'm going to have a graph over it. So for that, I'm going to have a cost underscore graph, and then I'm going to have a labels over it as well. Now for the labels, now I'm going to show the labels. So it's like plt dot x label. Now for the x, so I'm going to have the number of iterations, iterations, and plt dot y labels. So here we have a cost of our function, how much cost do we lost and how much cost do we left, and the plt title of my blog is cost per iteration, iterations. Now I'm going to show the plot through which I'm able to identify the function. So this is my plot. This is my graph of my cost. Now, the last part, but not the least, for the gradient descent, I'm going to figure it out, the linear line out of my data. So I'm going to find out the linear line for the plotting data do I have. So how much plotting data do I get and how much data do I have left in my concern? So it's all about the plot dot scattered. So I'm going to have a scattered graph in which between x and y, I'm going to have a scattered graph. Now the predict value, so it's PRE is equals to M multiplied by x plus b. So it's the predict value I'm going to find out with the help of the function. It's like, oops, we got, so it's the function between the prediction. So this is our linear function. So I just put it here. Now the predict values and now the plot between the prediction values. So I'm going to plot my graph. It's like plt dot plot between x and predict and c, which actually shows the regression. So I'm going to show with the variable r for the regression, and plt dot I'm going to put x label. Now this time I'm going to use Again, the same way, the hours of study in my data set, and for the Y label, it's like Y label. Now this time again, the test score as we have above, SCORE scores. Now the best for the title, I'm going to make it sure that best points where our line connected towards the point. So plt.show. Let's see what we shall get. So this is our linear point with the help of gradient descent and linear regression function. Now with the help of gradient descent, I'm going to able to predict the values. What values do we get in the future? So I'm going to make a prediction graph. Yes, the last of today's session is the prediction graph, through which we are able to identify with the passage of time what graph do we get. Now the last part of today's class is, with the help of number of iterations with gradient descent, So now the part in which we are going to have something important. Okay, so we are going to have to import matplotlib as plt, and now animation. So you are going to able to find out matplotlib dot animation. For the future concern, you are able to find out what kind of graph do you have. So animation, animation. Now import numpy as np. It's fig.plt.figure, and I'm going for the x-axis. So for a is equals to fig dot add underscore subplot and 111. It's just a random value, so it's totally up to you what kind of random value you're going to put. So it's underscore b underscore progress, progress, progress from 0, and it's for m is equals to m underscore progress, which is also start from 0 right now. Now the predict value, so predict, which is equals to m multiplied by x plus b. So this is our prediction value. Now the line, animation line, and how we are able to find out the between the predictions. So before that, line is equals to that I can plot on the x-axis and between the prediction points. So I'm able to find out the prediction with dash. Dash can be good. And C is, as I told you, the reference for the R as well. So with initialize of array of 0, that's an important point. Now for the function animation, where I'm going to use the animation, it's define animation or the animate. Let's see, it's I comma b underscore progress, prog, and m underscore progress, prog. Not going to use a full formation. So it's predict, which is equals to m underscore prog, that's an I, multiply by x plus plus b underscore, okay, underscore prog of I. So that's a way we are going to utilize our all functions. through which we can have the things in which we are going to simulate a lot of things in different ways as well. Now, for the prediction part, it's line.set underscore data between x comma predict and return line. Now the animation, it's any which is equals to animation animation dot. Now the functional animation is func animation animation between the peg and animate and frame, frame is frames. I'm going to define which is equals to the length of the data. How much do we have? It's b underscore progress comma frags farg is frags, which is equals to also b it's b underscore progress and m underscore progress as well, comma, and x dot scattered. So actually the graph, let's see, ATTER between x and y. Now the HTML part, which I'm going to utilize here, it's ANI dot to underscore JSHTML. Let's see. Okay, fig.plot.figure. That will create an issue. Why it's creating an issue? Okay, yes, I got it. So it's actually not this one. And yes, we have our value, in which actually the value is here. So if you are going to have a button, so it will show you the progress like this one. So in the coming time, how much your data will be go up, it will reflect also. And once your data is go up, like go up and stop. So this is how we're going to animate each and everything from the prediction. But right now, what data do we have? It's this way. And in the future, our data will go up and it will show actually the data of the linear regression. So if you're gonna say it in loop, so yes, you can play the whole function in loop again and again and again and again. So this is our today's lecture in which we are able to find out the linear regression and the model of linear regression between our data and our graph. So the next lecture is regarding each and every criteria of a function do we used before and after of it. So till the next lecture, see you.